Hello everyone, welcome back to our channel. In this video, we are going to discuss about reinforcement learning problems. Uh, Reinforcement learning problem is a type of a problem in machine learning or RL and AI where an agent learns to make decisions by interacting with the environment to maximize the reward signal. And the main goal is to find a policy that maps from states to actions in a way that maximizes the cumulative reward over the given time t. So, really, RL problem is nothing but an agent is placed in an environment and must learn to make decisions to achieve a goal. So that agent can receive the feedback from the environment in the form of rewards or penalties, which guide its learning process. So RL problem is nothing but the components are agent where agent is a decision maker or a learner that interacts with the environment, and environment is an external system that responds to the agent's action, and state is nothing but a representation of the environment at the given time t, and action is set of all possible actions taken by the agent, and reward is nothing but a feedback signal that indicates the desirability of the agent's action, and policy is nothing but a plan or a strategy that maps from states to action, leading and guiding the agent's behavior that guide the agent's behavior. And what is value function means? Value function is nothing but a function that can estimate the expected cumulative future reward from a given state. And q value function is also a function that can estimate the expected cumulative reward from taking a given action in a given state. The main RL problem involves finding the policy which maximizes the cumulative reward over the time t. And this can be achieved through various algorithms like Q-learning, SARSA, and DQNs and policy gradient methods. So in RL, problems can be classified into different categories like episodic and continuing and deterministic and stochastic, where episodic means the agent can learn from sequence of episodes where each episode consists of a fixed number of steps, whereas in continuing, the agent learns from a continuous stream of experiences where there is no clear distinct between the episodes. Deterministic is nothing but the environment responds deterministically to the agent's action. And when we discuss about stochastic, the environment responds stochastically to the agent's action. So, RL problems have numerous applications like robotics. RL can be used in robotics to teach robots new skills such as grabbing an option, objects, or things around the environment. And it is also used in game playing to create AI agents that can play games like Go, poker, Pokemon, and video games. Autonomous vehicles also, it is used to teach the self-driving cars how to navigate in a complex or busy streets, and it is also used in healthcare to personalize treatment plans for patients with the complex diseases, and then it is also used in finance to optimize portfolio management and also in trading strategies. So the problem in RL is lies between how an agent can learn to gain a higher cumulative reward by following a policy pi in a given time t in an uncertain environment. Uncertain is nothing but a random environment. So these are the few challenges or problems in RL where exploration and exploitation means nothing but balancing the exploring and exploiting the new states. Suppose imagine you are at a new restaurant and you don't know what's good. Do you try something new or order something you already know you like, or you like something? Exploring is nothing but trying a new dish, or exploiting is nothing but a you already like a dish that you are ordering it again. So RL also same. RL agents also same face the same situation whether to choose the new action or exploit the previous actions which led to higher cumulative rewards. So, overexploitation can lead to slow down learning, and while overexploitation can prevent the discovery of better strategies. If agent exploits the previous actions, there might be a chance of having a better plan or a better strategy. By exploiting, we can something that can prevent from discovering the better strategies means they can have a much more better than the previous actions which lead to higher rewards. But what if we explore another? We might have also get some more rewards, like it can simply say that regret or having some more high reward by choosing that actions. Like exploration also can slow down the learning. It might also be like lesser rewards without choosing the previous rewards. So to balance these two, we have to balance both of the exploration and exploitation. This is a challenge for the agent. So it also might face the same dilemma what to choose. And when delayed reward means like you think of a playing a game where you don't get a reward until the very end. It's hard to know what action lead to what reward, right? So the RL agent also faces this problem when the rewards are delayed. The reward may get for an action after many steps. So it will be hard for agents to face these problems when rewards are delayed. And when we talk about credit assignment, the credit assignment problem arises when the agent needs to assign credit to each action in the sequence, determining how much each action contributed to the final reward. So it is also a challenge where which past actions can lead to that reward. If you choose an example like playing a chess game or and the move made early might contribute to winning or losing. So if you made a move at the starting first, at the end of the game, uh, for choosing that one move, you may win or you may lose. So that might be a problem. So the agent needs to credit and assign assign a credit for every each action in that sequence. Which action you are choosing, it should assign a credit. So this might be a bit problem for the agents. So let us consider an example where same robot plays a game of chess and the robot makes a series of moves and eventually if an opponent checkmates, the agent checkmates the opponent, then it receives a reward. So the robot needs to determine which specific move it should make to the checkmate the opponent so it can learn from its experience. And when we talk about the partial observability, partial observability is nothing but agent does not have complete information about the environment means like take another example like playing a game where you can't see anything or you can't see the whole board. You just have to make the decisions with the limited information. It doesn't have any information like. So this might be the problem for the agent when the environment is only partially observable. And in large state spaces or continuous state spaces, the agent might get trouble because trying to navigate a huge maze, it's hard to know where to go. RL agent may face this problem when the environment is so large or very complex. And when we talk about non-stationary environments, let's take us an example like playing a game again where the rules keep on changing, and the it becomes so hard for the agent to adapt to that rules and change those rules and making it update up about those rules. So our agent faces this kind of problems when the environment is not stationary. We'll be taking the stock market, dynamic traffic conditions, and some more examples. And when we talk about reward shaping, it is designing good reward functions. So, in designing good reward functions in reward shaping is so difficult because when we take an example about teaching a child to clean their room, you have to shape their behavior with rewards. Like if you say a child for clean the room, I'll be giving you a chocolate or complete your homework, I'll be giving you any chocolate or reward. So by improving their behavior, you can reshape your children's behavior, right? So same RL also faces this problem when the reward function is not well designed. Next, ethical and safety considerations. This might be develop RL agents might develop unintended behaviors that maximizes rewards in ways not intended. So it is nothing but in a game, an RL agent might learn to exploit bug or glitch, get high scores, right? Rather than playing a game as intended. In a self-driving car, an RL agent might learn to drive recklessly or ignore traffic rules to reach its destination faster. So, critical applications in healthcare and autonomous driving, wrong decisions made by RL agents can have severe consequences, such as in healthcare, an RL agent might recommend incorrect treatments or dosages leading to harm or even the death of the patient. In autonomous driving, an RL agent might also make decisions that can cause accidents or injuries. So we need to be take careful design and testing of those agents to prevent unintended behaviors and ensure safe decision making. RL agents must be designed and tested carefully with considerations for potential risks and consequences. Today's video on RL learning problem, and we have covered the basics, components, processes, challenges, and applications of RL. I hope you found this video informative and helpful for you. If you have any queries or any topics you'd like to discuss, please leave them in the comment sections below. Don't forget to like and subscribe for more